All right, let's talk about one of the most famous stories in all of science, Isaac Newton and the apple. Now, you've probably heard it a million times, right? But the real story, well, it's not actually about an apple bonking him on the head. It's about a question that would literally change how we see the entire universe.
I mean, you can picture it, can't you? There's Newton, just sitting there, maybe having a quiet moment under a tree, and then boom! An apple falls. The legend, of course, says that this was his big aha moment, that he instantly figured out gravity. It's such a simple, powerful story, and honestly, it's no wonder it stuck around for centuries.
But like most great stories, the real version is a little different. It's a bit of a simplification, sure, but that falling apple, it was absolutely a real catalyst. See, it wasn't about him discovering gravity in a flash. It was about how that super simple, everyday event sparked a whole chain of questions in one of the most brilliant minds ever.
Okay, so let's move past the legend and get to the really good stuff. The real genius here wasn't just seeing the apple fall. Anyone could do that. It was about the incredible question he asked himself right after. And his first question is so powerful because it's about something we see every single day and just take for granted. Things fall down. Duh, right? Of course they do. But Newton, he actually stopped and asked, why? Why do they always fall straight down, not sideways, not up? That was the absolute key. That first step, he questioned something that seemed completely obvious.
Okay, and this is where things get really wild. His next question was just this incredible leap of imagination. He literally looks from that little apple on the ground all the way up to the moon hanging in the sky and wonders, wait a minute, is the same force that pulled the apple down also keeping the moon up there? Connecting the earth and the heavens like that, that was a truly radical idea that was going to change, well, everything. Now, answering a question that big wasn't going to be another aha moment. No way. This wasn't some sudden flash of insight. This was the result of years and years of super careful observation, deep thinking, and a ton of intense math, all of it leading to one of the most important scientific laws ever.
And that, of course, is his law of universal gravitation. Now, I know the official definition can sound a little, complicated, but stick with me because the core idea is actually breathtakingly simple. It's this: every single thing in the universe is pulling on every other thing. We're talking everything from a tiny grain of sand to a massive, distant star. It's a rule that applies absolutely everywhere.
So it really just boils down to two simple things. First, you've got mass. The more stuff an object has, the stronger its gravitational pull. It's why you feel the Earth pulling on you, but you don't feel the pull of, say, a tiny pebble. And second, there's distance. The farther you get from something, the weaker that pull becomes. That's it. It's this really elegant, predictable relationship.
But this is where the idea goes from just interesting to absolutely revolutionary. See, Newton's law didn't just explain why stuff falls. Oh no. It completely unified our understanding of the entire cosmos.
And this really gets to the heart of it. The force that makes an apple drop to the ground is the exact same force that keeps the moon locked in its orbit, looping around and around the Earth. Before Newton, people thought these were totally separate things, like Earth had its rules and the heavens had theirs. He came along and said, nope, it's all the same set of rules.
I mean, you have to understand what a huge shift in thinking this was. For thousands of years, people looked up at the sky and thought the heavens were this perfect, divine place with its own special rules. Newton just shattered that idea. He showed that the very same force that pulls a piece of fruit out of a tree was also guiding the planets in their orbits. All of a sudden, the universe wasn't this big, mysterious, unknowable place anymore. It was a rational, predictable system that we could actually figure out.
And the ripple effects from this? They were just immense. Newton's work on gravity didn't just solve one big puzzle. It literally created a whole new foundation for science, a foundation that we'd be building on for hundreds of years.
His law was a total game changer for physics and astronomy. I mean, for the very first time, we could predict how planets moved with incredible precision. This framework was so powerful, so solid, that it was the bedrock of physics for centuries. It basically set the stage for the next huge leap in our understanding, which would come from Albert Einstein.
Just let that sink in for a second. For more than 200 years, Newton's law was the explanation for gravity. It wasn't just a theory, it was the law. It helped power the Industrial Revolution. It guided our entire understanding of the solar system. I mean, what an incredible, incredible scientific legacy.
And that brings us right back to the apple, doesn't it? In the end, the story isn't really about the fruit.
The apple is just a symbol. It's a symbol of curiosity and of the incredible power that comes from looking at the world around you and having the guts to ask that simple but oh so powerful question, why?
You know, that one question about a simple falling apple ended up revealing a fundamental law that governs the entire cosmos. It just goes to show you that the biggest, most world-changing discoveries can start with the simplest little observations. Newton's question changed everything. So what's yours?